This video is a continuation of the previous video in which we stopped the lecture uh, explaining the difference between the pass by value and pass by reference, and I have given some examples. In this video, I'm going to continue from where I stopped last time. However, it's worth mentioning that this PowerPoint file has been modified by removing some slides that are found to be in broad kind of details for this subprograms passing parameters. So please download the most recent uploaded PowerPoint file for the sake of this chapter coverage. Parameter passing methods of major programming language continues. We're gonna still talk about this parameter passing methods in some major programming language like C, C++, and Java, which share more or less similar concept, pass by value and pass by reference. In C, for example, we have both of them. However, pass by reference is achieved by using pointers as parameters, as we'll see in one of these examples coming up in the next slide. In C++, there is a special pointer called reference type for passing by reference. And for Java, all non-object parameters are passed by value. So no method can change any of these parameters, but object parameters are passed by reference. This example from Java explains the difference between pass by value and pass by reference, in which you see that in pass by value, the value of the variable is passed. So for example, in this function, the original value of age is not changed when the variable age here is passed as a parameter to this increase age function. The only way to change this value is to change it inside the function in the return statement. Like this example here, for example, is going to change the variable age by adding 1 to it, so it becomes 15 when it is actually being called here and passed as a value as an argument for this function here. But pass by reference, which you could see that we are using pointers. This star here before the name of the variable and star here before the name of the variable. Here, for example, they are getting the value from the location where this variable is stored by using this ampersand here. So before actually passing here this parameter or this argument, the variable original value is 15 in its location. So the new variable value, which is 15, has already been passed. So again, this method is similar to those of C and C++ as well. All C languages, they follow the same method. Fortran 95, they use in and out mode. In and out mode as parameters, so that in is a parameter that goes in, and out is the result of that parameter after it has been changed. I don't have a code in 95, in Fortran 95 to show you, but I'm going to show you a similar code in PL/SQL. For example, I have here here in this program, I'd like to show you an example by creating a subprogram. I'd like to create a subprogram that as a function, a subprogram as a function, and then use the in mode for this function. So here I have this example where I have a function called test employee number from the database. So I use in. So I'm going to actually pass in an employee number as a number, as an integer here, as int or a number. This is the data type, and it's going to return Boolean, which is either true or false. This function is to select the total number of employees from the employee table, such that it returns true if there is an employee with that number that is going to be passed as parameter to the procedure. Otherwise, it's going to give me error by using this exception. So let me first create this function, and after I create the function, so the function actually is going to stay in the database as a name. So this function, if it is created successfully, is going to be created with this name, test underscore employee number. Now let me actually create another subprogram as a a procedure. This one is going to be a procedure, because a subprogram could be a function or a procedure. So this one is a procedure to test procedure. Again, I'm going to use employee number variable or parameter as an in. That means something that I'm going to pass in to get the result out. So this one is going to be created as I have mentioned in a video before, that the procedure, once it is created, can be executed using that function. So because here, if you look at this name here, this is what it is. This is my function. Test employee number is my function. So I'm going to use this if statement, like if the function, if the employee number that passed as a value, as a parameter to this test employee function, if this is true, tell me that the employee with that number is found in the database. Otherwise, tell me that this employee number is not found in the database. So it is just an if-else statement in this programming language. So for example, if I would like to test that, I'm going to use this this name here, test employee number, to execute it by using begin, and then end, and then in the middle here I'm going to execute my procedure, the procedure with this name, which is test pro, but I'm going to actually pass an employee number from my table. Let me first show you my tables. Select employee numbers from M. See all these employee numbers, guys, from the first. Let us select one of them and test it. So if we choose any one from these, like 7788 for example, and we pass it here as a parameter, as an in value. So if I tested that, of course, you're going to tell me that this employee number is available. Let me put a semicolon here. Execute again. This employee number is found in the database. 77 is found. But let me check another one that is not here. Let me just make up anything like 7888 for example. Just let me put 778 0 for example, which is, I know it is not one of these employee numbers in the database. So if we executed that, it's going to be, this one is not found in the database, and so on. So this one is a parameter that has been passed here to this procedure, which is a subprogram that takes the whole function, which is another subprogram, as a program inside itself, so that it can execute the in parameter as you could see here in this code, like here, in. So the in and out, the in and out. Sometimes you have an out parameter also inside this header of the function or the procedure in some other examples. But this is a quick example to show that they're using in out and also in out mode as well in 95, in Fortran 95 and other versions after 95. Plus, of course, other programming language like this programming language that I'm using, this example, which is PL, SQL, PL, procedure language, of the structured query language. This is just one of the examples that we can use in out mode. In C Sharp, default method is passed by value. But if you would like to pass by reference, you have to precede that variable name by the word ref. And in PHP, for example, it is very similar to C Sharp, except that either the actual or the formal parameter can specify the ref. But in C Sharp, both formal parameter and its actual parameter with the word or the concept or the operator ref is used. But in PHP, either the actual or the formal parameter can specify the reference. Not you have to use one of them to specify inside your PHP code. Swift programming language, the default also is passed by value. Most of this language, by the way, the default is passed by value, but passed by reference is possible if you can use some specified or predefined concepts. Like, for example, the formal parameter here is specified by this keyword in out. Also in Perl, I think I have also example in Perl that shows all actual parameters are implicitly placed within predefined array, which is the at with underscore. The at with underscore that you will see here, or just at sometimes. In Python and Ruby, they use pass by assignment. All data values will be considered as objects, and the actual parameter is assigned to the formal parameter. So it's just like swapping or switching. This is in Perl, I think. This in Perl language, in which you are using the here in this line here. This is a function called my, right? And the parameter, there is this parameter here. Each variable I and j here preceded with this dollar symbol as in PHP, and it is assigned what is assigned to this at underscore. So, and then when they are printing it, they're printing it to us by assigning the variables to the at and the variable name, which is the variable name itself is preceded by the dollar. So they use this reference for by reference, not like C Sharp where they use ref. So they use a symbol here in this one. Not only in Perl, but also there is other languages that specifically the server side, scripting language. They use some of them. They use the at. Even in PHP, sometimes you will find this reference like that. Type checking parameters. This is very important for reliability in programming. The type checking, to check the type and data type of these variables. There is no type checking in Fortran 77, and also the original C language, there is no type checking, but it is required for some programming language like Pascal and Java, and but for also and C and C++, born on C++. So this is totally left to the programmer or the user. Sometimes they are used prototypes where they can actually have this type checking. However, in prototypes, the variable names themselves are not required. What is required is the type or data type of these variables, given that you put them in the correct order. But these new languages like Perl, JavaScript, PHP, they don't require type checking. You know that in JavaScript, all variables are declared with just var, for example. In PHP, there is no data type at all. You just put a $sign for the variable name, whether it is a variable name or parameter or an argument. In Python and Ruby, also the variable do not have types, but the objects do have types. Types means data type, and what data type they are. So parameter type checking is not possible in Python and Ruby. If we talk about multi-dimensional array as parameter, yeah, sometimes, of course, not only multiple dimensional array, one-dimensional array, two-dimensional array, multiple dimensional array are all possible to be passed to subprograms as parameters. And but these subprograms, if it is implemented like multi-dimensional array, if it is implemented or passed to these subprograms, is going to be actually these subprograms should be compiled separately. So the compiler actually needs to know the size of these arrays so that you can build a storage mapping for these functions. I have an example, I think, for this multi-dimensional array passed as parameters in the next slides. So in C and C++, so the programmer is required to include the size, the declared size for these arrays of all of them, except the first subscript, because the first subscript is just compared to the rest of this subscript because it's default no, it starts from the number 0 if it is not specified in the actual parameter passing. But in order to overcome any issues for the size, you have to pass a pointer to the array, which is the storage location, where the storage location will determine the size of the dimension. So the user must include the storage mapping function in terms of size of the parameter, because these parameters need to have the correct mapping. Like this example here, for example, the size, if it is a size, is being declared here as 2 by 2. This is a multi-dimensional array or two-dimensional array in which we have like a matrix of 2 by 2, like a table by 2 by 2, 2 rows and 2 columns, for example. So this is actually can be passed to a function like here in this example. Let me just make this a little bit large to show you what I'm talking about. Here in this header line, this is a function called display numbers. Display numbers is a function that doesn't return any value, but it accepts as an integer the multi-dimensional array num22. Where is num22? Num22 in this C++ program has been declared here in this line as a multi-dimensional array. So there is 3 variables, 2 variables, I and j, plus a multi-dimensional array, which is num22, which is 2 rows and 2 columns. That has been passed to this function. And also, when you print out this function, this is actually a C programming language, not C++. because here they are using printf and using also scanf to get the value. So here to print the arguments of I and j, which the counters that stores the two-dimension array arguments. In Java and C#, they are similar to Ada. Arrays are considered as objects. They are all single-dimension array. They don't allow for a multi-dimensional array except in user-defined some user-defined subprograms, and arrays can be regarded as objects. So each actually array inherits its name. It's named from the built-in constant, like in Java, for example, like the length in Java, which is the length of the array, the length of the array. Like for example, here I write, for example, in array, like using a for loop, like for var in Java, or for JavaScript, for r, for var I equals 0, for example, I less than array dot length dot length, and then I plus plus, like that. So in this code, you will refer to the length here. Array, it inherits the size from this keyword that is set to the length of the array when the array is created. So if the array is created, like for example, the array is created like this, var cars, and then a, b, whatever, and then c, and so on, d. This array, this is a single dimensional array, is size 4, 1, 2, 3, 4. So the length refers to the how many values being declared in the declaration, or in the declaration of this array. So in Java or JavaScript as well, in C#, it is set to the length of the array when the array is created. But so these elements can be the values inside that array. It is sometimes convenient to pass subprograms names. Subprogram names themselves are passed as parameters, as we have seen in the previous programs I showed you here. You see, this is a subprogram. Test employee number is a subprogram. Is a function that I created earlier, and then I am passing this number inside the subprogram as an argument. So it is sometimes very convenient to pass these subprograms the name as parameters. It remains some issues like the parameter type checking. So is the parameter type checked? Is it type checked or not? And also one of the design issues is what is the correct reference environment for a subprogram that was sent as a parameter. The correct reference environment. The environment, we're talking about the environment, talking about does it refer to these subprograms as package or as functions and if they are functions, are they separate functions or part of a package, or are they triggers, for example? So the environment that this subprogram is pointing to is one of the design issues that need to be known before passing these names as parameters. So these are challenges that face some programmers when they are actually using parameters, when they are using subprogram names as parameters. Also, you can actually call these subprograms indirectly. So if there is a lot of subprogram to be called, the correct one on a particular run of the program it doesn't seem like it is a clear passing, or it is not known until the execution, like event handling, for example, or what's called exceptions, event handling, like exceptions, for example. So in C and C++, for example, this reference is made through the pointers, which it will guarantee a reference to the location where this variable exists. So if there is many different subprograms to be called, which is repetitive calls or frequent calls to these subprograms, and the particular run of the program is not known until the execution. So you can call these subprograms indirectly through event handling. Event handling, like exception handling, for example, in C or C++ or Java. In C#, for example, you can use pointers. Pointers are implemented as objects. They are called delegates. After you create this as public, you can use the keyword delegate and then specify the data type, if it is an integer, for example, and then use that parameter here. So this delegate type name change, for example, in this example, can be instantiated with any method that takes an integer and retain an integer. So this is a retain type. This is a retain type. Just imagine that this change is a function, okay? And this integer is the retain type of the function. And this function change will retain an integer, right? It accepts an integer, which is x, and retain an integer. So this integer value is passed to this function, and also retained by the same function. This is a C# code, which can be instantiated with any instantiated with any method that takes this integer parameter and retain also an integer value. A method also as a static can be used. Static, however, it will keep that variable value as not change, as constant. You know, it can be passed as a value and then retain with when the function actually stopped executing, it will go back to the original value stored in that variable. So a delegate can store more than one address, which is called multicast delegate. But they have to be of the same method or the same method pointer, which is a delegate. It has to be of the same data type. The data type that it receives, it is the same as the data type that it returns. Some design issues or side effects. Parameters should always be in mode to reduce the side effects. So these parameters like in the program I have shown you earlier in PLSQL, should always be an in mode. Also, in some most imperative language, it restricts the return types. C, for example, it allows any type except arrays and functions. So they can have any data type that can be used. Restriction is only can be seen when you use arrays as parameters or functions as parameters. In C++ also, like C, but it allows user-defined types. So you can have your own user-defined types for some objects that you're going to create in the program, whether private or public. But methods are not types, because methods are not typed in C# and Java. C# method can retain any type, but methods cannot be retained, of course. In Python and Ruby, for example, Python and Ruby treat methods as first-class objects, so they can be retained as well as other classes. So these design issues are part of the design issues for functions in some programming language, like in Ada, C, C++, C#, Java, Python. They all have different issues regarding the parameter passing. But to be clear, simply programmers should start creating these variables from the beginning as objects, so that they can reduce this side effects. And when they pass these variables, they pass objects that they have different data types. Because of these objects, they are not type checked. With regard to overloaded subprograms, an overloaded subprogram is a subprogram that has the same name as another subprogram in the same environment, in the same program. So many different functions have the same name and maybe returning different types or returning different data types values. In C++, Java, C#, all include predefined overloaded subprograms, of course. In Ada, the overloaded function can be used to disambiguate calls, like two overloaded functions can have the same parameters with the same names, but the only difference will be their types. An example. For example, you have always passing the same numbers, but sometimes you are getting float, sometimes you are getting double, sometimes you are getting integers, but it is the same program. The same program with the same name, but passing same parameters but getting different data types. These data types will be sometimes not known as different types until you produce the result, and that even the result is going to be seen as the values that existing in the memories at that time. And what I mean is that you might have the same program, like 3 different programs producing the same result and producing even the same number. You look at the number after the program is finished, and you see these are exact numbers, 12, 12, 12. So what's the difference between them? The difference is that the first 12 is an integer, the second 12 is a float, the third 12 is double, and you don't see them like that on the screen or in the environment, but inside the computer memory they are stored as different data types, so that when you use them in future processing, like multiply them or add to them or something like that, so the integer will result in an integer, and the float will result in a float, and the double will result in double, and so on. Generic subprograms in C++, like this version of generic subprograms are created implicitly when the subprogram is named in a call, and when its address is taken with this at operator. If I have, I can show you a small program here with C or C++. To show you this, but this example I'm going to show you, I'm going to show you just subprogram based on the main function, where the operator and or ampersand is used to get the address of these variables rather than the values. So for example, let me just create a very small program that explains this concept. All right, here, for example, this program is using these parameters n1 and n2. So I have given this program in the previous video to show you the difference between parameters and arguments. So here it is, which is the result of G1 minus G2 here in this subprogram. But let me I like to use the ampersand and ampersand and see what am I going to get. All right. Can use ampersand in the parameter. Maybe it doesn't accept it here, but let me change this program slightly so that it can use this. So cout n1 and cout n2. All right. So here, let me use end line to give me a new line. Let me just remove this prototype and execute this program. I would like to show it as simple as that. So this one will give me the two numbers, which are 10 and 20, like that. But now I'm going to use this ampersand thing, which is this, instead of just a variable. I'm going to use the ampersand before it. So here I'm getting this reference. These two values are the memory address. This is the memory address of the where the variable 10 is stored, and this is the memory address where the number 20 is stored. I could have used it in a bigger program to show you this in the context of you know, of subprograms, but simply you can have this like this in one program to show you that these two are the first two are actually the values, and the second are the location or the reference for them. You know, and line, yeah. So just let me execute this one. So 10 and 20 are the values where the actual values of these variables, and the second two values, the location of these, or the memory address, the address where these the address is where these two numbers exist in the program. Also, generic subprograms are preceded by the template. Sometimes you can use template in C and C++ language. You can use template. This template, it can be created as generic. Generic means this program can be used for any other subprograms. If you'd like to compare between two numbers like first and second, for example, to see if first is greater than second, then display first, otherwise display second. This is a template, which is like a container for this function called max, in which it has the two variables first and second, and here you see we put type and type. What's type? Type is my custom made data type. It is not an integer, it is not a double, it is not a float, it is not a character, it is not a string. So you can use anything. You can use anything. If you use the word any here, then you can also use it here. Any. So it is a programmer defined type, so to speak. So it is actually generic. Here, this concept closures, a closure is a subprogram and the reference environment where it was defined. So the referencing environment is needed if the subprogram can be called from any place in the program. And for the static scope language that does not permit nested subprograms, it doesn't need these closures. But these closures are actually needed if the subprogram can access variables in nesting scopes, like a program inside a program, for example, or a function, a subprogram inside a subprogram, and it can be called anywhere inside the program. The only thing that you need to worry about is the scope, where these variables are public or, I mean, private, local or global. To support closures and implementation, we need to provide unlimited extent to some variables, because these subprograms might access some variables that are no longer existing in your program. Maybe they are using some global variables that are existing outside of these functions. So you have to provide this environment, to provide this extent to the environment and show the environment where these variables are declared for these subprograms. Otherwise, there will be a lot of confusion for the program itself, specifically in case of the nested subprograms. A Java closure, for example, can use some, you know, multi or nested function like this. So this is function called make address passing value called x. But look at the function. What does it retain? It retains another function called whatever name it is, but it is actually passing this variable y. So now here you are declaring two variables like add 10 and add 5, and each one is assigned to a function with specific parameter. The same function here, make address, this one passing this argument. That means the return value of this one is again stored in a variable, and the return value of this function is again stored in a variable. And these variables again used in this object with document.write statement to display these values, which is here, add 10, and again passing a parameter here to them. So this one is actually passing a parameter 20 and passing a parameter 20 to address 10 and address 5. What is address 10 and address 5? Address 10 and address 5, these two variables here are declared to hold the return value of these two values. So like here, I would say it's like a nested kind of subprograms. And so the closure is anonymous function retained by this, it's called make address. Now it's going to be anonymous. Anonymous means it is used without any precondition. It can be used in any place as long as you pass it the correct data type. If it is an integer or if it is a double and any other data type can be passed to it. In C#, we can write the same closure using nested anonymous delegates. So instead of these variables themselves, you need to precede when you retain a value, and when you retain these values, you have to return the value with its data type specified, but this is preceded with the keyword delegate. But so the return type is actually, the return type is specified inside the parameter. But usually this is not the case in C and C++ and Java. This is the case only in C#, where we can write, these closures programs to specify the delegate that takes as an integer as parameter, and retain an integer as well. Here, for example, if you put static, and this is a function name called func, it accepts these two data types, integer and integer. If you look at this, you'll see that these two doesn't have any names inside them. So that means what matters here is the data type of these two parameters. And when you pass these two parameters to these functions, it is known these are two parameters. Like, for example, the first one passed here and here. And the first one passed here, 5, and passed here as 20. Both of them are integers for both variables. This is just a code in C#, which you can see that also it uses assert function to retain some specific values. So here you can see that you can assign specific closure to variables like this one. Here function 1, f and h. This is f and h. This is f and h are defined here as function. Each one accepts the same parameter x F, and H, and each one accept one value, which is 1, 1. This is variables assigned values, and then assigned to two new variable called A and B. Then when using this closure stored in the variables, you can use them by using A and B and pass any type of or any number to them and reassign them to specific values. Coroutines also is a kind of a subprogram that has multiple entries and control them itself inside multiple entries that has multiple entries and controls them itself, like in Lua programming language. Also, you can find this in other programming language. Simply, this coroutines are like generalized subroutines or subprograms. They have what is called multitasking. They allow execution to be suspended and resumed again from one side of the program to another side of the program. They are similar to loops or infinite programs. Let me show you here a picture that shows this kind of coroutines. Here in this diagram, you can see that if these two different programs. So here the program started and then it resumed. It went to B, sent as parameters to B. Execution happened here and B, so it resumed at A, and then comes back to B, and then processing happened in B, and then goes back to A. In A, some processing occurs, and then at this point it resumes, it stops, and then it resumes again from this point in A and goes back to B. And then a lot of programs or execution occurs in B, and then transfer goes back to B. Then from here it starts execution at A, and then at A also some processing occurs, and the continuation it continues like that. So simply, this coroutines are computer program components that generalizes subroutine for non-primitive multitasking by allowing execution to be suspended and resumed later. So they are really very suited for implementing similar program components like exception handling, like event loops, triggers in database, for example. If there is an infinite list or pipes, these coroutines are sub programs that can handle such kind of programs. So there is only, they have multiple entries from both sides of this subprogram. It has multiple entries because if the suspension stopped at one side, it is continued on another side. Simply, this subprogram definition describe the actions represented by these subprograms. Can be either functions or procedures, as we pointed before. And also local variables of subprogram can be static, dynamic, or static, as we explained. There are three different models for this parameter passing, either in or out or in-out. So some languages, a lot of languages, they allow operator overloading, but some programs they don't. Some programs can be generic and some programs can be not generic. Also, the two concepts that have been explained at the end, the closure and coroutine. A closure is a subprogram, and its reference environment is very important. And also, a closure is a special program with multiple entries, as we explained in this diagram.